接下来的演讲活动，我们很高兴邀请到的是 Lion Microsystems Limited CEO Dr. Abraham， 为我们带来的是 Multi-band Multi-standard Transceivers 多频段多宽频标准具有优秀射频表现的收发器。现在就让我们以掌声来欢迎 Dr. Abraham。
Thank you. Thank you very much for the introduction. I almost understood what was said about me. So, actually, the topic of my talk today is all about software-defined radio and the chipsets and the ICs which would enable the realization of such platforms. For those who are not familiar with software-defined radio, and the term used there, we were talking about smartphones just a minute ago. It really is a farmyard of transceivers, power amplifiers. You have 2G, 3G, and now LTE is coming up. And all of those require a specific transceiver to be used in those type of contexts. So you will find as we go from standards to new generation of standards, we are going to be using more and more transceivers in any platform that we design. So it is always understood in our industry, in the hardware design of transceivers and communication, wireless communication systems, that software-defined radio is the way to go. You essentially have one set of chipsets which are highly programmable, and you can switch between standards. So the key aspect of this for now and up to now has been the fact that it's very difficult to make these things cost effectively. It's very difficult to make them highly integrated, and as a result, it has not been taking off so far. But now there are chipsets coming up that makes this software-defined radio a reality, and that's what I would like to concentrate in my talk today. The agenda for my presentation is quite simple. I would like to start with an introduction, telling you a bit about our company, what we do, and essentially dive into the concept of software-defined radio and look at the application areas that could make use of such device. And we as a company, together with a number of FPGA or field programmable devices, are trying to make the adoption of this technology really widely used out there. And one of the key concepts of doing that is essentially using through a medium called open source. I'll highlight that a bit more in my presentation. And to demonstrate that this is not an academic exercise, I would like to highlight some of the products that makes use of these type of concepts. And certainly, we do see future platforms making much more use of such concepts going forward. And finish up with a summary of important points, which essentially brings out the key elements of my talk. So a little bit about Lime. The company was founded back in 2005, and it's backed by very large venture capital firms in Europe. So our headquarters is based in the UK. And obviously there is a huge amount of sales and marketing efforts in the US, where we see majority of the market share coming from that part of the world. And obviously Far East is a very significant market for us. And more recently, we have partnered with Azio Electronics, who are representing us here in Taiwan. And they are putting a lot of business as well as application support behind our product to make sure that it's widely used in this part of the world as well. The flagship chip that we are promoting is really a field programmable transceiver. Without it, no mobile communication can be done. So transceivers are hearts of wireless communication. And what we've been able to do is to make these transceivers field programmable. So essentially, you can program these devices to be anything you want it to be. You can make it a 2G transceiver by just programming it. You can turn it into a 3G transceiver all the way up to LTE, working in a number of bandwidths that are available for those type of standards and beyond. So we see this as a future for transceivers going forward when we go from 2G all the way to 4G and beyond, those type of applications. So essentially, the whole idea is to come up with one circuit which can address the global market. So rather than having individual chipsets addressing segments of the market, you have one chip that fits all. And that's the way to go. This is happening in the base station area today, and we see this happening into the mobile phone going forward. So essentially, rather than having 7 or 8 transceivers dealing with things like Bluetooth all the way up to LTE, you will have one transceiver that switches between these standards, especially so that you're not running them concurrently all the time. As Lime, we really are focused in making the adoption of the technology widely used out there and making sure that this type of platform gets used everywhere. And I'll come on to that a bit later because I think that's a very important aspect of what we need to do in order to achieve global usage of such devices. So looking at the application area, today we see that base stations are going to get smaller and smaller. As we go from 3G to 4G, no longer the macro base station is going to determine the data coverage as well as high-speed data. We are going to smaller and smaller base stations, even as small as a femtocell, which you would have in the corner of your home. So you would have essentially your own base station to communicate. And these are gaining momentum. Last year, there were about 2.5 million units of femtos deployed worldwide against just 200,000 macro base stations. So you can see that these type of platforms are going to gain a lot of interest out there, especially so that you're going to be switching over to the standards such as LTE. Again, within the infrastructure market, repeaters are invariably used to give you coverage. So a flexible radio of the kind that I'm talking about is finding itself in these type of application areas where potentially the volume could be reasonably large. On the other hand, you have application areas such as military radio, satellite communication, or white space. These require really high performance, and typically they operate in frequency bands that are not covered by your usual standards covered by these type of devices. So these are, I would say, non-cellular type of applications where a flexible radio will make a huge impact. And to demonstrate the fact that if you have a single chip solution, highly integrated, you could not only address these type of markets, but you could go to volume type of applications, covering things like CPEs, home gateways, as well as machine-to-machine applications. These machine-to-machine applications are becoming very important for monitoring things such as power grid and so on. So potentially the volumes could be very high, and each of these would operate in specific bands of interest around the world. As a result, you need a flexible radio to do that. But really the main topic of my discussion here is really around software-defined radio, and in particular, its linkage to FPGA. Because together with a transceiver, which is flexible, and FPGA, you would be able to implement any standard you want. And I will come up with examples to demonstrate that this is doable and it's done. The medium by which we want to make this generally available in the market is through open source, and I will come on to that a bit later in my presentation. So it's quite important to see through all these application areas that if you have one transceiver addressing all of these, you will have volume. And you would be able to cost reduce, and you will be able to improve performance. Otherwise, you will end up having a transceiver for this